On today's episode of Building Blocks of Bharat, we have a very specific focus on our anchor Arjun Bhagat, who is exploring a range of architectural techniques and advances that tying with the idea of structural engineering as we understand today. Hi, I'm Sneha Gupta and welcome to our show. In this episode, we look at domes, arcs, pillars and doors and see the science of how they come about. Our journey takes us through the dome of Humayun's tomb. The first true arc built in India was at Balban's tomb. The enormous doorway of Fatehpur Sikri and astonishing rust-free pillar at the Qutub complex sounds fascinating. Well, with that, we move ahead.
Arjun's first stop is in the World Heritage Site of Qutub Minar in the Mehrauli Archaeological Park. The Qutub Minar is an architectural masterpiece which is made of red sandstone. The minaret is 72.5 meters high, tapering from 2.75 meters in diameter at its peak to 14.32 meters at its base, with alternating angular and rounded flutings. The surrounding archaeological area contains funerary buildings, notably the magnificent Buland Darwaza gate, the masterpiece of Indo-Muslim art built in 1311 AD. But before we explore Qutub groups of buildings, Arjun heads out to find the tomb of Ghiyasuddin Balban. The tomb is eerily deserted and pretty much in ruins. What then brings us here? Well, it is this arch, which is historic, because it is considered by many architectural experts as India's first true arch ever constructed. And it took a long while before it arrived in India in the year 1287 CE. Almost 2000 years after it was used in other parts of the world. Before exploring a true arch, let us first understand what an arch is. Simply put, an arch is a curved structure that supports or strengthens a building. The arch is considered a key architectural element. It is present in both the Sumerian and Etruscan civilization. But it was during the Roman times that this feature was perfected. How does an arch work? Almost all arches span openings and support weight above them. Others are enclosed in walls. They could be made of many materials: stone, brick, concrete, or steel. Now, an arch that is made of stone or brick consists of a series of wedge-shaped blocks called voussoirs. During the construction of such arches, the blocks are supported by a wooden frame. The last block to be inserted is the keystone, the center stone at the top. It is this keystone, the wedge-shaped stone at the very top of the arch, that locks all the other stones of the arch into position. The keystone bears no weight, but is the center of redirecting the weight of the structure down and outwards. The secret of keeping the arch up is the way the pressure is transferred down the length of the arch. The pressure of each side of the arc against the keystone supports the arch when the frame is removed. In addition, the arch is supported on both sides by masonry or by other arches to keep it from collapsing under the weight above. Very simply, the arch stays up without any beams or anything else to hold it up. Wondering why? Well, the central block stays up because it is wider at the top than the bottom. So to fall down, it would have to push the neighboring blocks outwards. As long as these are held securely, the central block can't fall down. The ancient Indians didn't use the arches much in their temples or other constructions. They employed posts and lintels, or corbelling, in order to span openings. Let's understand some of these architectural techniques. So what is a lintel? A lintel is very simply a beam across two posts. The function of a lintel is just the same as that of an arch or a beam. However, lintels are simple to build and hence were used a lot in architecture. What is a cobbled arch? A cobbled arch is built by letting successive stones overhang slightly. The steps produced by the cobbled construction are then hewn away to produce a smooth profile. Like many of the arches within the Qutub Minar complex, like this at the Quwwatul Islam Masjid complex. Even all the balconies of the Qutub Minar itself have arches that are cobbled, not true arches. So this arch was the first true arch ever made in India. Kind of special, right? And after that, once the arch made its appearance, there was no stopping it. The Mughals took the arch and used it in different ways to create some of the finest buildings in the entire world. Akbar's tomb at Sikandra near Agra, Humayun's tomb, and of course, the Taj Mahal with its use of pointed arches. Let's head back to the Qutub complex to check out one more kind of arch. This is the tomb of Iltutmish, one of the slave rulers of the Delhi Sultanate. His tomb is a square chamber topped by a circular dome, which is where the problem arose. How would a circular dome fit a square base? Which is where a special kind of arch, known as the squinch arch, played a role. So what is a squinch arch? In architecture, it is a construction filling in the upper angles of a square room so as to form a base to receive an octagonal or spherical dome. This is considered as the first monument in India to use this technique. The dome, which stood on these intricate arches, unfortunately collapsed at some point of time. Some experts believe that it was a result of structural flaws in the building. But another significant dome which has survived the passage of centuries and also lies in the Qutub complex is the Alai Darwaza, a domed gateway built in 1311. The main structure of the Alai Darwaza consists of a single hall. The domed ceiling rises to a height of 14.3 meters. The recessed corner arches of the attractive horseshoe forms, supporting a simple spherical dome on top of the square chamber, are an especially happy solution to the perpetual problem of supporting a good dome. The slave dynasty did not apply true Islamic architecture styles and used false domes and false arches. This makes the Alai Darwaza one of the earliest examples of first true arches and true domes in India. It is also interesting to note that the three doorways on the east, west and south have horseshoe arches. The entrance of the north is a semicircular arch. The other thing to note is that when local builders in India finally mastered the art of constructing domes, they built them as half domes, that is, domes that did not sketch a complete semicircle. In fact, most Indo-Islamic monuments until the 15th century had half domes, and it is only with the buildings of the Lodi dynasty between 1451 and 1526 that the domes began to curve a full semicircle. And so, Arjun sets off to explore in more detail the dome in the beautiful Humayun's tomb in Delhi, built in 1570 CE. This is believed to be the first distinct example of the Mughal building style. This tomb set the norms that were taken forward with later Mughal mausoleums, especially the Taj Mahal. The Humayun's tomb is set in a geometrically arranged garden, crisscrossed by numerous water channels, symbolically representing a paradise. The stunning interlaced marble and sandstone facade in Humayun's tomb is crowned with a large shining dome of white marble. Before exploring this dome in more detail, let us first understand what a dome is. A dome derives from an arch. It consists of numerous two-dimensional arches rotated around their midpoint, creating a three-dimensional structure. However, when these arches are rotated, something remarkable happens. The keystone, that crucial element at the top of the arch, becomes unnecessary when they transform into a dome. The very top of the dome can be left open without compromising its structural integrity. This hole is also known as an oculus, and it allows light to enter the space. The advantage of a dome is that it can enclose an enormous amount of space without the help of a single column. Its beauty aside, Humayun's tomb is significant from an architectural perspective. This was among the first structures in India to use a double dome. So, what is a double dome? It is a dome with two layers. There is an inner layer inside, which provides a false ceiling to the interior of the building. The other layer crowns the buildings itself. The devices of double dome enable the ceiling inside to be placed lower, keeping the proportions of the interior space intact, while increasing the elevation of the exterior. There is usually a gap between the two layers. This device gave a building an imposing exterior height, but kept the ceiling of the central hall in proportion with the interior heights. The dome is also remarkable in that it is the first major full dome to be seen in India. Earlier domes were not full, in the sense that their shape never traced a full semicircle. The outer dome of Humayun's tomb is 42.5 meters high, covered with marble and bulbous in shape. Umbrella-shaped chhatris, small turrets, supported by columns, stand around the main dome of the roof and give an Indian impression. The inner dome, 12 meters under the outer dome, makes a favorable ceiling height for a volume of 3 floors for the central tomb hall, which serves a pivoting role, connecting itself with the surrounding rooms and 4 Iwans.
Here we will take a short break. After the break, we will discuss more on this topic. Welcome back after the break. Knowledge of geometry and laws of statics also have played a leading role in their choices of various types of arc. The arc was first employed for structural and functional purposes, but gradually it became used for decorative purposes.
But now, let's move back in time to explore another interesting Mughal structure, Buland Darwaza at Fatehpur Sikri. We are on our way to Fatehpur Sikri to check out the highest door in the world. This structure, called the Buland Darwaza, or literally the lofty gate, was a triumphal gateway built by Emperor Akbar to commemorate his victorious campaign in the Deccan. It took 12 years to build this massive gate, which is 40 meters high. On the outside, a long 12-meter flight of steps sweeps down the hill, giving the gateway additional height. So all in all, it rises to an imposing 52 meters above the road. Let's take a look in a little more detail. The proportions of the door are perfectly symmetrical. To make an entrance of this proportion took careful planning and precise construction techniques. Remember, this was nearly 700 years ago. There were no cranes and heavy moving equipment or mechanized cutters. The principal arch of the door stands in the midst of 3 projecting sides of an octagon. The 2 adjoining sides are broken into 3 tiers. Crowning the whole is a parapet topped by freestanding chhatris, which are dome-shaped elements commonly used in Indian architecture. The Buland Darwaza is made of red and buff sandstone, decorated by white and black marble. The inlay work of the marble and sandstone is unique to the masons of the Mughal period. On the eastern arch of the Buland Darwaza, a Persian inscription records Akbar's conquest over Deccan in 1601 AD. This beautiful city, built by Akbar as the capital of the Mughal Empire, survived for only 14 years. The mighty resources of the kingdom could not save the city from the scarcity of water that plagued the area. We have one final exploration in this episode, and that takes us back to the Qutub complex. This time to study this sleek tapering iron pillar that stands at the center of the Quwwatul Islam Mosque. But there is a larger mystery surrounding this pillar. Something that has puzzled historians, archaeologists and metallurgists for over a century. This pillar is made of 90% wrought iron and has stood for over 1,600 years without rusting. Before we understand how that happened, let's look at this pillar in a little more detail. Dating back to the 4th century CE, the pillar bears an inscription which states that it was erected as a flagstaff in honor of the Hindu god Vishnu and in the memory of the Gupta king Chandragupta II. So the pillar must have originally been located in Madhya Pradesh. How the pillar moved to its present location still remains a mystery. The pillar stands about 7.2 meters high, of which 93 centimeters lies below the ground. Its diameter varies from 29 centimeters at the top to 42 centimeters at the bottom. The metal of the pillar is pure malleable iron. The manufacture of such a massive iron pillar, which has not deteriorated in 1600 years, is a testimony to the metallurgical skills of ancient India. Now let's get into some detailing of the iron pillar. The pillar is rough within a few hundred centimeters of the ground and is smooth and highly polished at eye level. The rough surface near the base is apparently due to ineffective welding during forging. The upper part of the column is so highly finished that it is sometimes mistaken as bronze. The bronze color may have been due to embedded sand or to a thin bloom of ferric oxide viewed at an oblique angle. Now the skills of the metallurgists are clear when one looks at this pillar. Produced from high-class iron, this is the biggest hand-forged block of iron from antiquity. Experts believe that Indians were the only non-European people who manufactured heavy forged pieces of iron, and the pieces were the size that the European smiths did not learn to make more than 1,000 years later. And why has it not rusted when one compares this pillar with the iron beams used in the temples of Puri and Konark? These have undergone a high degree of rusting, even though they are only about 700 years old. The climate of Delhi is fairly dry. It is known that serious corrosion of iron does not take place if the critical value of relative humidity is less than 80%. At Delhi, the relative humidity exceeds 80% for only about 20 days in a year. Therefore, the atmosphere in Delhi is not very conducive to rusting of iron. The most interesting theory believes that the lack of rusting is because of the properties of the iron, which is believed to have a high level of phosphorus. Scientists have also discovered that a thin layer of mesa white, a compound of iron, oxygen and hydrogen, forms a protective film over this pillar. The protective film took form within 3 years after erection of the pillar and has been growing ever so slowly since then. After 1,600 years, the film has grown just 1/20th of a millimeter thick. Experts believe that the protective film was formed catalytically by the presence of high amounts of phosphorus in the iron, as much as 1% against less than 0.05% in today's iron. The high phosphorus content is a result of the unique iron-making process practiced by ancient Indians, who reduced iron ore into steel in one step by mixing it with charcoal. A magical combination of science and mystery.
We have been on quite a journey through arcs, domes, pillars and doorways in this episode of Building Blocks of Bharat. We have much more lined up for the next time. We will see you again in our next episode. Please share your views or suggestions on feedback@indiascience.in. Till then, good day.